Hi everyone, this is going to be a quick video where we discuss the power rule for logarithms. So the power rule for logarithms is a rule that allows us to think about how do I deal with exponents. So if I have an input inside of a logarithm, so any logarithm, and I have a term that has an exponent in it. So when I look at something like this, what I'm looking for is I have something inside, an input into my logarithm that has an exponent in it. So there's going to be some base to an exponent. It doesn't matter what they are, but these are the kind of things that I'm going to be looking for. Right, so if I have something like this, what the power rule for logarithms says that I can do is I can take this exponent and I can move it down out front as multiplication. Okay, so I can take it down out front of multiplication, and what I would get is this is the same as W times log base B of U. So I'm going to go ahead and erase this red text, and what I end up getting is I get the power rule for logarithms, right? So log base B of U to the W is equal to W times log base B of U. Now, one of the things that we're going to see is you can go sort of in two directions with this. So if I have a term that looks like this on the left-hand side, as I mentioned earlier, I have this exponential term, so there's something with an exponent inside of a logarithm, I can bring it down out front like this. Or if I have a logarithm and something is being multiplied out front by it, what I can do is then take this and rewrite it as an exponent. So the rule actually goes two directions, so I could take this and make it an exponent, or I can take exponents and bring them down as multiplication. So one example that we might see is a question like this. So perhaps I want to evaluate a term log of 100 raised to the 52. Okay, so if I have log 100 to the 52, now if I try to go about this in a direct manner, and I try to evaluate this term 100 to the 52, well, that's going to be a 1 with a whole lot of zeros after it. So it's not going to be a good strategy for me to try to evaluate this term. So what I want to do instead is I'm going to use my power rule for logarithms. I'm going to take this 52 and I can bring it down out front. Okay, so I'm going to take this 52 right here, I'm going to rewrite it out front as multiplication. So this is equal to 52 times log of 100. Okay. Now, log of 100, if I think about this, this is much more reasonable for me to evaluate. So I ask myself, all right, log of 100. So we have to remember that since there's no base here, it's really a 10. So there's an implied 10 that's really in there. So we don't write it, but for now, I'll put it in there just so we can think about it. And I'm going to ask myself a question, 10 to what power gives me 100? So if I think about that, 10 squared is 100. So log base 10 of 100 is 2. All right, so if I keep going here, I get 52 times 2, and 52 times 2 is 104. So with the power for logarithms, instead of getting a giant term as an input with this right here, it allows me to rewrite it and to compute something a little bit more reasonable. Alright, so I'm going to pause the video here, I'm going to clean it up, we'll come back with one more example where we can put some of our rules together. Alright, so we are back, and I have another example in front of us. So log base 5 of x to the 5th divided by y squared. So what I'm going to try to do is expand this out using some of my rules for logarithms, just as some practice. So what I need to do first is look at my input here, x to the 5th over y squared, and ask myself, what is the structure of this term? You know, is there some term raised to an exponent like I have for the power rule, or is there something else going on? Now, if I look in here, the x term, I have x to the 5th, which looks like this, and I have y squared, which looks like this, but the entire input does not have this form. It does not look like u to the w for some u and some w. So I have to think about it separately. I have to do something before I can use my power rule. And the thing that I'm going to do is look at this division. I say I'm dividing two things. So if we remember, we have this rule for quotients that says I can take my numerator and write it as a logarithm and subtract what I have in the denominator. Okay, so I can first rewrite this as log base 5 of x to the 5th minus log base 5 of y squared. And so I use the quotient rule for logarithms. And now what I have is I have two separate logarithms here. So I have log base 5 of x to the 5th, log base 5 of y squared, that do look like this. I have some input to an exponent, just like these terms up here. So this 5 I'm going to bring down out front, and this 2 I'm going to bring down out front. So let's go ahead and do that. All right, so this 5 will come out front, and this 2 will come out front of this logarithm. So we get 5 times log base 5 of x minus 2 log base 5 of y. And so now this expression is totally expanded, and if I wanted to evaluate it, I would have a less complicated input. So I don't have this as an input, but I have some easier things. I only have an x as an input and only have a y as an input. Right, so what we're doing is practicing our rules for logarithms so that in the future we're going to see how we can use logarithms to help us solve exponential equations. All right, so I hope this helps with the power rule for logarithms, and I'll see you next time.